All right, let's just jump right in with a simple question. Think about the air you're breathing right now, and say the phone in your hand. I mean, they couldn't see more different, right? Well, today we're going to explore the hidden world of what scientists call matter and uncover a pretty surprising connection between them.
Yeah, one's totally invisible, the other is, well, solid. But what if I told you that deep down, they're both made of the exact same basic stuff? The only difference is how that stuff is put together.
So to really get this, we've got to zoom in, way in. We're talking shrinking down to the size of an atom and exploring this incredible world of tiny particles. It's a place where everything you can think of, from a giant star millions of light years away to a tiny grain of sand on a beach, is made of the same basic ingredients.
Right, so scientists have a name for all this stuff. They call it matter. And here's the first big kind of mind-bending idea for you. Nothing is truly solid. Nope, not even that phone you might be holding. It's really just a buzzing, vibrating collection of countless tiny, tiny particles.
Okay, you might be thinking, prove it. And we can with a super simple experiment you could totally do at home. Just imagine this. You take a glass of water, mark the water level really carefully, and then you dump in a spoonful of salt and stir it up until it all just disappears. So the salt is gone, right? It vanished. But here's the crazy part. The water level doesn't move. Not even a little bit. It feels like a magic trick, but I promise you it's pure science. So where on earth did all that salt go?
And this is what's so cool. It proves that matter is actually full of empty space. Those little salt particles just snuck into the tiny gaps that were already there, in between all the water particles. It's kind of like perfectly fitting puzzle pieces together where you didn't even know they were holes.
Okay, so we've nailed down one huge idea. Matter is made of particles, and there's space between them. But believe it or not, there's more to the story. Turns out these particles follow a few really simple rules that explain, well, pretty much everything, from why ice is solid to why you can smell dinner cooking from another room.
So let's crack open this particle rulebook. We've already got rule number 1 down. They have space between them. But the other two are just as important. For one, particles are always moving, just constantly and randomly zipping around. And at the same time, they're always pulling on each other. They're attracted to one another.
You know, this constant motion thing, it's exactly why you can smell a delicious pizza from all the way across the room. Those little pizza smell particles are literally on a high-speed journey, just weaving through the air until they find their way to your nose. And get this, the hotter the pizza, the more energy those particles have, and the faster they travel to you.
And that attraction force, think of it like dancers on a packed dance floor. They're all kind of pulling on each other. In some materials, like a solid, they're locked in a super tight embrace, and it's almost impossible to pull them apart. But in others, they're just loosely holding hands, ready to break free and do their own thing at any moment.
So here's where it gets really interesting. What happens when these two big forces, this constant motion trying to fling particles apart and this attraction trying to pull them together, what happens when they go head to head? Well, the result of that epic battle is the 3 states of matter that we see every single day: solids, liquids, and gases.
Yeah, it really is a constant battle. And it's simple. When the force of attraction wins, you get a solid. When the energy of motion wins, you get a gas. And what about when it's kind of a tie? Well, then you get a liquid, which gets to have the best of both worlds, in a way.
Let's go back to that dance floor analogy, because it's perfect here. In a solid, the dance floor is so jam-packed that the dancers can only vibrate or shuffle in place. In a gas, it's a completely chaotic mosh pit. Dancers are flying everywhere, bouncing off the walls. And in a liquid? Well, in a liquid, the dancers have enough room to slide and flow past one another, but they're still pretty close.
Okay, so we've got our 3 main states of matter down. But what if we want to, change things up a bit? How do we actually turn a solid into a liquid, or a liquid into a gas?
Turns out we have 2 main tools in our toolbox for this: temperature and pressure. Think about it. When you turn up the heat, you're just giving those particles more energy, making them move faster and helping them break free. And when you crank up the pressure, you're literally squeezing them, forcing them back together again.
Now, this is where things get a little bit weird. Let's say you're heating up some ice. The temperature goes up, up, up until it hits exactly 0 degrees Celsius. And then something really strange happens. The temperature just stops. It gets stuck, and it will not budge until every last bit of that ice has melted. The exact same thing happens again when you boil water at 100 degrees.
I mean, it's a genuine scientific puzzle, right? You're pumping all this heat in from your stove, you can feel it, but the thermometer's needle is just sitting there, not moving at all. So if that energy isn't making the water hotter, where's it all going?
Well, that energy is going towards a secret mission. It's being used to break the bonds holding the particles together. Think of it like a key unlocking a cage. This hidden energy has a name. It's called latent heat, and it's the absolute secret ingredient for changing states. It changes the form of the matter, not its temperature. And then you've got the real rebels of the matter world. Take dry ice, for instance. It doesn't even bother with the liquid stage. It just skips it completely and goes straight from being a solid to being a gas. This awesome shortcut is called sublimation, and it really is like a magic disappearing act. All right, so we've looked at the big, dramatic ways matter can change state, like melting and boiling. But what about the quieter, more subtle changes? The ones that are happening all around us, every single day, without us even noticing?
Believe it or not, even in a perfectly still glass of water, there's a nonstop party happening right at the surface. The most energetic, hyped-up particles are always making a break for it. They literally leap out of the water and escape into the air as vapor. That whole process, that's evaporation. And yep, it's happening right now all around you.
And this invisible process, this is exactly why you feel so cool and refreshed after you hop out of a pool on a hot day. It's not just in your head, it's actual physics in action on your skin.
It's basically your body's own personal air conditioning system. As that water or sweat evaporates from your skin, those escaping particles take your body heat with them. They literally carry the heat away, which is what leaves you feeling cooler. And that, by the way, is why wearing a cotton shirt on a hot day feels so good. Cotton is great at absorbing sweat, giving it more surface area to evaporate and cool you down even faster. So when you think about it, from a simple puddle on the street to the sweat on your skin, the whole universe is just this grand, intricate dance of tiny particles. These simple rules we talked about, space, motion, and attraction, they're the choreographers, and they create everything we see and touch. But it leaves you wondering, right? What about the places where the rules get pushed to the extreme? In the insane gravity of a black hole, or inside the fiery heart of a star? What other bizarre, exotic states of matter are just waiting for their turn on the stage?